And now I'll show you the termite clump. This I'm about to show you. They were live or dead as two different treatments in my experiment. I'm going to show you the live termites. So in the process of this, I measured the likelihood that the ants would make physical contact with the introduced object, and I measured how they changed their direction upon coming within a body length of the object. So for some of these, you'll see that they're just going around it. For some, you'll see that they're turning all the way around.
Not a lot of behavior from a live termite
Huh?
there? Not a lot of behavior on the part of the live termite?
Well, actually, I'll address that afterwards, but I did use multiple ones so that their glue would stick them together so that they wouldn't walk away, but they were still moving around and squirting. So I took behavioral data from the first 10 ants that passed within a body length of them, and I scored them if they touched the object, and I scored them for different levels of change of direction. And so these are the probabilities that for a given treatment, the first 10 ants will touch the introduced object. So compared to the control, the dead termite treatment was not significantly lower in the probability of being touched, but the live termites were. So this I interpret as the ants being repelled by the live termites, squirting them away. So this is the behavioral mediated defense that I was testing for, and we did see it here. And I also think that this has to do with the ants getting repelled before they even have a chance to smell the termites to exhibit the avoidance behavior that they seem to be showing in response to the chemicals. And so the direction changes are consistent with the avoidance model without the deterrence of the termite behavior. We see that they avoid the dead termites and the live termites, or they divert their path significantly more than control in response to both termite treatments. If we set the threshold a little higher and say that they have a large diversion of their path, it's still significantly different between dead and live, or compared to the control. And if we say that they have to turn completely around, like you saw in the video, some of them went up to the termites, walked away, that's only significantly different from control in the live treatment. So it seems that the ants they're diverting when they get to these termites, but more dramatically from the live termites. So this is just a combination of both chemically mediated and termite defense behavior mediated avoidance on the parts of the ants. So they're getting attacked and they're getting away when they know they might be about to start getting attacked. So we see acetonbercelli avoiding termites in response to olfactory cues. We see this being exacerbated by the termites' defenses, and we see this being independent of termite cast. The independence from termite cast is different from a lot of the other, or different from the other documented ant termite interactions that have come across in which ants avoid termites. There are cases where ants will avoid soldier termites, as I said earlier, but avoiding both soldiers and workers is strange. And so this is strange. Why avoid the termites? I mean, why not eat them? They're a super abundant potential source of food. They make up an enormous amount of the insect biomass in tropical ecosystems. Other ants eat termites. Why can't these guys? These are some of the most famous and deadly army ants out there. And acetonbercelli does raid other social insect nests. It eats primarily other ants, and it is able to overcome ant defenses. Ants are not helpless, and it could overcome defenses. So why, for these termites, why is it avoiding them? So one possible explanation for this is the life dinner principle, which is a concept in evolutionary biology that's best explained through a quote that's given when it's described, which is, the rabbit runs faster than the fox because the fox is running for its dinner and the rabbit is running for its life. Here we have the termites as the rabbit and the army ants as the fox. The termites have to defend themselves from predation or they're going to get eaten and they're going to die. The ants have other options. As I said, they eat pretty much everything. They'll eat scorpions, other ants. They could do without the termites. So, and more formally, this is the life dinner principle is when an asymmetrical selection pressure has asymmetrical evolution, causing one of the species that are interacting to out-evolve, as the paper calls it, the other. I don't really like the terminology out-evolve because that's weird, but it makes a point. But since the termites, as I said, are fighting for their lives, and the ants are just fighting for another appetizer in their huge smorgasbord, it could be that both of these groups have come to the conclusion evolutionarily that they won't gain anything from interacting with each other. The ants will get stuck up and killed by the termites' poisonous glues. The termites will die in the interaction, and they don't ever want to have to deal with the ants. So they could have evolved to just keep contact to as much of a minimum as possible. And so this is interesting because then we have here this evolutionary relationship between these ants and these termites that we don't see enacted as an interaction in nature. And these army ants and these termites appear to have some relationship to each other, but this manifests itself in them not interacting. And these sorts of hidden relationships, these fascinating evolutionary stories that produce what we see today in nature, could be hidden all around us, and we would never know until we start trying to feed things to other things. So I'd like to acknowledge everybody who made this possible for me. Thanks to the Kaminsky Family Fund for paying for me to do this. Thanks to my parents for collecting data with me. My dad was my research assistant. My mom helped me analyze the videos. It's awesome. Kessler Family Science. Thanks to Mike Logan for lending me this awesome camera, which I also could literally have not done this with. To Francisco Campos and Carlos O'Driver and OTS for just accommodating us on short notice and really making everything happen. Obviously, Matt Ayers and Mark Hausbeek for advising me through this whole process, helping me go from, I like ants and termites, to getting to something that's a project, to Christoph and Sebastian, two researchers that helped me find the ants when I got to La Selva, who were just awesome. They literally put flags on the bivouacs. To the other researchers in La Selva who helped me, to Nate Dominy for originally believing in me for a thesis, even though that didn't work out, to the Phillips Institute of Science for keeping me excited about science, and to the several people who sat through my presentations or read my several terrible drafts and just gave me so much more help than I deserve by orders of magnitude. And to the people who fed me and offered emotional support, and to all of you guys, thanks so much for coming out. This was great. So, yeah. Any questions? Yeah.
I'm curious why, so I don't think you did this experiment of putting the glue on a Q-tip. Did you?
I didn't. I wanted to, but I didn't have, I only had what I brought with me, so I didn't have the ability to do that. I would have
You
loved
brought
to
the
do.
glue with you?
To extract the glue?
Oh yeah, to extract the glue. I actually tried to, there was this iguana scientist that I tried to borrow, that I borrowed syringes from, but they still weren't small enough to get the glue. Yes, I tried to do that, and I would have loved to do that. It would be fascinating to
So
see.
what
about
would
that.
you predict you would see if you put glue on a Q-tip?
Glue on a Q-tip. I would predict that the ants would be repelled probably a similar amount to the crushed termite experiments, because I think that there was some of the glue was released in the process of crushing the soldiers, and the soldier and worker levels of avoidance were about the same. But it could be even more avoidance if it was actually more released that way.
Well, what about in terms of live versus dead termite?
What do you mean by that? Sorry.
So you had 2 experiments in the second round,
Yeah.
right, where you had the live termite versus the dead termite.
Yeah.
So do you think the glue would mimic which one?
Oh, in that one, if I were to have a glue Q-tip instead of the termite clumps, I think that would mimic the dead one, because I think part of the reason that the type of avoidance that we saw was occurring, this is totally speculation, but I think that the type of avoidance that we saw in the live treatment, such as especially the lack of touching, had to do with the action at a distance of the glue. So before the ants were able to get up and investigate the introduced objects, they were probably getting squirted from like up to a centimeter away by the termite. And if I put the glue on a Q-tip, I think they would have to come up and close to identify it, and then if they did, and they are responding to this with an avoidance behavior, then they would avoid it in a similar amount. The actual direction change part might correspond more with the live treatment, though, because the actual turning away instead of just avoiding could be a response to the glue and not to the termite chemicals. That's what I would just predict.
What actually eats the termites in the system, and how does the glue factor into that relationship?
There are other species of ants that do specialize on termites. There's, I could actually, let's go back several slides. I could show you a picture of one of them. I didn't really go into this, but one of the ants I showed you a picture of earlier is a termite specialist. It's a Dodonocus, the trap-jaw ant. I don't know if I'm pronouncing it right, but it has a ballistic motion of its jaws that's able to sort of snap and often kill the termites before they're able to do too much with their defenses. Even when it is attacking the termites, they find that it does suffer some consequences, and around 25% of the time the termites are able to get away. But they're usually pretty successful. There are other specialists. There's another type of army ant, that's the genus Nevia myrmex, that does group raids on termite colonies. Also some vertebrates like the Tamandua anteaters will eat termites as well. And glue, for sure, for the ants plays a part in defending them. Of course, not enough that the ants can't live off of them, but I think it repels the anteaters a little bit as well, but I don't know that. That's yeah, I don't know that for sure. Okay.
So is the head glue just deterrent, or is it toxic? So if these other ants are eating the termites, do they clip the heads off and eat their bodies, or what are they doing?
It is toxic. It does cause paralysis when it's squirted onto ants. I know that some ant species find the soldiers of some termites unpalatable and will preferentially eat the workers. I don't know if it's toxic when ingested, though. That's a great question. It is